Right, hi there guys. I thought we might just start earlier tonight. I was gonna start at 9:45, but we'll just get everything started. So pretty much how this works is because I've done the live stream last year, and I did go through some questions, but I think because of UEGs and everything, I don't think there will be as many people on stream this year. So what I'll do, I'll try to help out with any individual questions that anyone might have. So so if you have any particular questions that you want me to go through, just fire away in the chat. Otherwise, I'm more than happy to wait until more people arrive. And but yeah, so this is your time that you get with me one-on-one, pretty much, because there are not as many people online at this stage. But if no one has any particular questions, I can just quickly go through what you can expect from the three topics in the externals. So just anyone in the chat, you can just send me a message as they can hear me okay, and if you have any questions, just chuck in the chat. Otherwise, I'm more than happy to wait till quarter to 10, where that because that's when the stream was supposed to start, but I thought I'll just start a bit earlier because a few of you are waiting. Okay, so if anyone has any questions, put that in the chat, and we'll get started on that. Okay, so first come first serve, and I'll try my best to explain. Don't put in the questions or I'll teach the entire flowchart. I'm not going to be able to do that. Okay, because you had an entire like 6-7 weeks to learn a topic. I'm not going to be able to teach you that in 20 minutes. Okay, so fire away with any questions if anyone have any questions. Or just people are very shy, or is it the chat not working for me? I'm pretty sure the chat is working for me. Yep, it's working for me. Live chat. Yep. Come on, any questions from anyone? Because that's pretty much how I would prefer to do this streaming from now on. Because like I've done quite a few exam videos in the past. You know where to find them. Just Alright, here's the first question. What happens when KSCN is added to iron 3 hydroxide in water? Okay, so what happens when KSCN is added to iron 3 hydroxide? If you could specify what standard you're looking at, but I know which one you're looking at anyway. Alright, so let's start with KSCN. So with KSCN, so I'm assuming that you are going to look at the precipitate of, oops, why am I using that? Right, there we go. Just make sure the screen's not as crooked as last time. Right, so KSCN, when you're reacting with iron 3 hydroxide, why am I writing this in words? So which is Fe OH3. Right, so this is where you need to look at, and trust me, this is much easier compared to previous years where they give you the complex ions. All right, so when you get a question like this is obviously from 3.6. This is your complex ion formation. So you have SCN minus here, and then you have Fe3 plus here. And this is where you need to understand, you need to go onto the resource sheet, then you will see there is a complex ion that looks something like this, if I remember correctly. Wait, yep, I believe, I don't have the formula sheet with me, but I'm pretty sure that's what it looks like. So you just need to understand that if you are putting iron hydroxide, which is a sparingly soluble solid, if you put this in water, what that does, it will partially dissociate or dissolve into this. Okay, now when you have this particular thing, the complex ion forming, so you need to write two equations here. Minus, this is going to be, yep, that's fine. So this is my equilibrium, and because of the formation of this complex ion, my Fe3 plus is going to be used to make FeSN2 plus because of the complex ion formation. So as a result, the Fe3 plus concentration is going to decrease, and then the system is no longer equilibrium. So how does the system respond to that? It's going to shift to the right to make more of these guys, and as a result, this particular solid will decrease in the concentration, so therefore solubility increases. Okay, so this is your typical excellence question for complex ion formation. My best advice is to, you don't have to memorize anything, to be honest. Look at the resource sheet. That's going to be your best friend. John, required thingies for esterification. Now there are two things that there are two types of esterification. So this is 3.5. So to make ester, you can do this in two methods. One is by adding an alcohol with a carboxylic acid, and in this process you need heat, which is normally just reflux, and you need acid, and you're going to make ester, and you're going to make water. Okay, the other method you can do this is by using alcohol, and then you can use an acyl chloride or acid chloride, doesn't matter which one it is, depends on which way your teacher taught you. I go with acid chloride. Now in this particular method, because acyl chloride are much more reactive, this is far more reactive, and you may notice there's a gap of things above here because there's no reagent for this process to occur. Okay, so if you're seeing a carbox, so this is actually a really good question, because sometimes you see flow chart like this, boom, boom, flow chart, boom, 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 and then over here they give you a box, and they go, where's my thing, Majiggy? And they go, all right, this is an ester. Like say, for example, this is CH3CO OCH3, and they may go, all right, what is this? What is this? And they will leave this completely blank. And you have, then from that, you have to know that one of those two solutions must be a acyl chloride because there's no reagents required. All right. Haley, easiest way to remember the different enthalpy equations. Enthalpy equations, they're only there's only two of them. One is this. Well, actually, there's quite a few. There are four of them. One is this. One is this. One is this. And one is this. All right. So formation. This is making something from the elements. So it's kind of like, you know, with my boy, we do Lego building a lot. I say, for example, if I want to make this particular block, like, you know, of structure, how do I what elements do I need to, what block of Legos do I need to make that? All right, so I need 2 carbon blocks and I need 3 hydrogen blocks. So this is formation. Okay, combustion is if I want to burn something, like say C2H6. All right, so by definition, enthalpy of combustion is, you know, this is combustion. So combustion means the amount of chemical energy required to burn 1 mole of this. So you just balance everything, the 7 over 2. So this is enthalpy of combustion. Okay. Now just remember the definition. All right. Enthalpy formation is the amount of energy required to or released when you form 1 mole of this. So this number should always be 1. Combustion is energy released when you burn 1 mole of the thing that's being highlighted, so you keep that number as 1. Okay. Vaporization is just turning something from liquid to gas, and then fusion is just going from solid to liquid, and that's how you can remember them. It's really just come down to practice. All right, next one. So would you go over unknown solution questions for thermal? Wondering if you could go over unknown solution questions. Could you give me a specific example, like when you say unknown solution questions for thermochem? You mean organics? Unknown solution? I don't think we do any unknown solution stuff for. So Diham, if you could, what I don't know, I don't want to butcher your name, man. If you could specify your question, please. Watching me on TV, thank you, right? Do we need to remember complex ion? Oliver, know all of the resource sheet. I'll actually find it for you right now. Let me just look it up. NCEA level 3 chemistry resource sheet. Chemistry resources. Sorry, I'm just looking at this on my screen. Resource sheet, where are you? There it is. All right, so so this is what we're looking at. So this is all the complex signs. So you're not expected to memorize any complex signs. So you guys are quite lucky, because all the year 13s would have memorized everything. They would need to know everything. Okay, so this is a resource sheet from 2020. It took me 10 seconds to find on the NCEA website. So you don't need to memorize anything. Would you say thermal organics more difficult? I personally think thermal is probably the hardest one to get excellence, because you have to write quite a bit, and if you're not very careful with your wording, then you will get punished. Okay, so organic is definitely, to me, easier, but Kevin obviously disagree. But maybe our ducks does have a point. But yeah, personally, I think Aqueous is by far the easiest. If you know what you're doing. Hi, so can you go over some equations in thermomechanics, like Hess's law? What we could do, because I did go through Hess's law quite a bit in my. If you go through my video list, you can find one. But let's just go through a 2015 exam. Let's see if there's any. This one, no, this one's not so good. Is anyone decent here? No, yes, no, yes, no. These ones all suck. They're not your typical Hess's law. So Hess's law, there are two types of Hess's law question. One is you get the enthalpy of formation of everything, and this one's better. All right, so if you want to give a crack with this one, let me just cut this bad boy. All right, so this question is quite good. So paste it. All right, so if you need help with Hess's law, so you came to the right place. So because there are not that many questions, so let's just spend a bit of time going through this. So this is from 2016. All right, let me just have the numbers handy, because I can't be stuffed getting my calculator. This is question number 3. Okie dokie. Okay, so this is your Hess's law question. So how do you know you got Hess's law question? You've been given the 3 enthalpy of combustions, formation, blah blah blah, and then you're trying to figure out this. Okay, so this is what I meant. You always want to put this equation right at the top of your sheet. Like this is everyone has a goal. You should, if you don't, you should set a goal for yourself. Like this is the goal of our question. We want to manipulate our equation so it looks like that. All right, so this is our ultimate goal. So we're going to put it right up there. We're going to work very hard towards it. Now for the enthalpy combustion, so this is I'm going to label them 1, 2, 3, so you know what we're doing. All right, so number 1 is enthalpy combustion. Combustion is C plus O2 turned into CO2. So this is, you need to be able to write this. All right, you need to be able to write this yourself, because sometimes, like you can see here, they don't give it to you. They don't have to give it to you. If they were generous, they could. Some years they do. Lucky for those students that sit through those years, but sometimes I've seen them not giving it, and you can't expect them to give it to you. All right, so this has to be halved. Now for this balancing equation, now remember the thing inside the bracket, which is this, the thing that I've highlighted, these must be kept as 1 mole, because by definition of enthalpy of combustion or formation, they have to be controlled as wrong equation sheet. They have to be kept as 1 mole. Bloody thing, where is it? Where's my OneNote? Here it is. As 1 mole per liter. All right, so number 3. All right, number 3 is the formation. So formation is CH3OH. So how do I make CH3OH? So I need C plus 4H2s plus O2, which is going to be halved, and this is -240. Okay, let me just double check. All right, see, I made a mistake there. That's not 4, that should be 2. And the thing inside the bracket needs to be kept as 1 mole. All right, so that's your first step. And if you do struggle with that, as a year 13 chemist, and if you struggle with the balancing equation, then I think we're little bit too far to go back to balancing equations, so you know you can work on that sort of yourself. Now, what we're trying to do, we're trying to manipulate these three equations so they add together to be something like that. So what we want first thing first, we want CH3OH on the left, which we have CH3OH on the right, so we're going to reverse number 3. All right, and what you could do, I'm going to do it for you guys, I'm going to write it because why not? It's very quiet. See, with the thing with UEGs, like a lot of people are not sending the exams, hence they're not turning up to this sort of tutorials, which is absolutely fine. Like I don't think too many of my students are going to sit the exams, which is a good thing. Now, number 2, what we want is that, now here's the thing, you don't want, if you look at the O2, you got O2 here, you got O2 here, you got O2 here, so you don't want to touch that, right? Leave that till the end. What we want 1 mole of CO2 on the right hand side, which we already have on the right hand side, yay. So we keep 1 as it is, so 1 stays the same. C plus O2 go to CO2, and then we need 2 moles of water. All right, so 2 moles of water. Where's water? Water is right here. I need 2 moles, so I need to multiply equation number 2 by 2. So that's going to be 2H2 plus O2 turning into 2H2O. So this number is positive 240 because it used to be negative. Now we reverse it. This is the same, which is 394, and this is 286. We multiply by 2, so it's that number. All right, and this is where the magic begins. You're gonna grab a different color pen. You go, all right, I got H2 on the right, H2 on the left, cancel. I have what else do I have? I have 1 carbon on the left, 1 carbon on the right, cancel. I have 2 moles of water. I have 0.5 on the right, so it's going to be CH3OH plus hope it's 1.5, yep, 1.5 plus 1.5 O2 turning into CO2 and plus 2H2O. And if you look at the thing that I wrote in blue, in green, colorblind there, is exactly the thing as what we have up here. That means you've done it right. Okay, now a lot of people actually, some of my students actually get stuck in. They're like, all right, so I managed to do that, then what the heck am I supposed to do here? See these numbers here? Add that up, and that's your answer. Okay, so that's your typical Hess's law. So these type of questions go straight up to excellence. If you only get the enthalpy of formations, those are only merit questions, and you do not need to do it this method. You just literally add up all the products, add up all the reactions. Just take a difference, and then that's your answer. All right. Can all standards, so I've done that. QMC delta T, or so I said it with your Q equals MC delta T. That question is actually quite straightforward. You just literally find numbers and just substitute into the equation. Okay, so if that question pops up again, I'll go through that. I'll just want to go through some of the other questions. Geez, I got a fan club, 1, 2, 3. Oh, nice account, man. Math is everywhere, so can you please go over solubility in acidic condition, how it increases, please? Now, I'm assuming that you're talking about how, like, say, for example, if so this is 3.6, how solubility increases in acidic condition. Your question again is incomplete. I'm just going to give you an example. Like, say, for example, I'm going to use the same question that we got previously, which is this. All right, so if I have this particular sparingly soluble solid, and if I want to dissolve this, like, say, if I want to compare, I want to dissolve this guy in, for example, HCl. How does the solubility increase? Well, because in HCl, what do I have? I have H3O plus and I have Cl minus. Oh, look at that. Look at the H3O plus. If I mix the H3O plus with that together, what's going to happen is these guys are going to cancel. These guys are going to get neutralized. And then this is no longer equilibrium because the concentration no longer stays the same. So what's going to happen? The system is going to shift to the right to make more of this. Therefore, this concentration, the FeOH3 concentration, is going to decrease. Hence, solubility increases because you have less of that. All right. Now, any strategies for doing all 3 papers, Oliver? I mean, at this stage, exams on Tuesday, you should know what papers you're going to sit. Like time-wise, or structure and bonding is going to take you more than 1 hour. I'm assuming you know everything. Organic is going to take you 15 minutes, and aqueous is going to take you 45. Okay, that's just how it is every year. So you shouldn't have time for struggle for time. Is more the strategy is you got to be realistic in terms of what your expectations are. If you are looking for triple E's, then you should have done at least 3 to 4 exam papers at this stage already, and you should be getting all of them right. And if you can do that, then triple E's looking very likely. If you're just going there for merits, then I suppose you can start working on the exam papers if you haven't done so. It's just grind exam papers, guys. I've seen the level 2 exam. It's very, very fair, very, very similar compared to previous years. No students complain, no teachers complain, and let's just cross our fingers say it happens to you on Tuesday as well. Can I give an electronegativity definition? Methods everywhere. Yeah, you've done that already for me. Thank you. What do you think? We're not talking about football here. We're going to talk about football later. Can you please go over condensation polymers? Condensation polymers. Okie dokie. So condensation polymers is an excellent question, right? And it's actually really, really simple. As long as you can copy paste, you will do really well for condensation polymers. So let's do a polyester. Let's say, for example, if I have, let's say polyester, let's not make it too hard at this stage. Let's say this is my, wait, should I do it this way? Nope, I should do it the other way. I don't want to do it like this. This is wrong. Let's do it like this. Actually, let's start from the easier part, because why not? Right. So if I have a monomer like this, because I was trying to do fancy stuff, but it might be a little bit too much at this stage. Let's just do that plus this. This is pretty easy. Let's add another carbon just in case. Right. So condensation polymerization. So this is the top thing is a carboxylic acid. The bottom thing is so the top thing is a dicarboxylic acid. The bottom thing is a dialcohol. Now the thing with condensation polymerization, guys. So you need to just I'm assuming you're on your own. Just do it like this. Just get your hands out. All right. You got your left hand. You got your right hand. And then what you're trying to do is that you need to understand that the condensation polymers, the monomers need to have 2 functional groups, one on the left, one on the right. They don't have to be the same, because if you look at proteins have different functional groups. But in this case, they got the same functional groups on the left and right. Okay, so if you were you have a sibling in the family, or your parents, one of the parents, and get them to stand next to you, then you hold hands. Then you think about if there are multiple clones of you and multiple clones of that particular family member, you can form an alternate human chain, just alternate between each person, and that's what condensation polymers are. So how does it work is that you just literally just copy paste. You just need to understand. Now this is again how I tell people, remind people to do it. Look at the function group for carboxylic acid. It's always they donate the H away, and then for the alcohol, it's always the OH. Excuse me. So how does that work? Is that these things are gonna go. They're not gonna be there anymore when they react. So obviously you need heat, heat and acid. Excuse me. Just gonna get some water. So how that's gonna go is that I'm just gonna copy paste here. Oh geez, I'm gonna use a different color pen. CH2, 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 and then you just do another one. I kind of run out of space, but you get the idea. Can you see this? So it's literally just copy and pasting. Can you see that thing? It's just the top bit,
and then the blue bit is just that bit. Okay, so you just copy paste, and then if you try to figure out, you know, if you want to go back, excuse me, let's say if I want to go back from the from this particular structure, I'll do it more correctly this time because I was trying to show you my my thinking there. Let's just do it like this. But sometimes they, man, I wish let me just find a question. It'll be easier that way. I need to get rid of the cough as well. So we got 3.5. Let's just find an old exam. 2015. Any decent 2.5? Because I hate writing those bloody this is about one. Yikes! Does this one do formation? Sure. Why don't we use this one? Let's just use a question. Question is always easier. Excuse me, jeez. Question is always easier to explain compared to a question there. All right, let's go with this one. So 1/6 so this is making nylon. So if I want to draw a monomer, you just need to, so what you could do, you know, if you're struggling with this, just copy paste, just put one of these next to each other. Just you know, as you can see right now, I'm just copy and pasting. Really no skill involved whatsoever. You know, you can just put one here. Just cheating a little bit, but it doesn't matter. Right. So when you do it like this, you should be able to identify that the Cl, one of the H's, they're going to bugger off and make HCl. This Cl is going to make HCl from the other side, which I can't fit. And one of these H's and this Cl is going to bugger off and make HCl. And this Cl and one of the H's over here, they're going to bugger off and make Cl. And then you just copy paste. Just copy paste what is left behind. So that's going to be CO. So that Cl is gone. So I'm just copying and pasting whatever is left behind. Yep. So this Cl is gone. And then I'm just going to copy that with the one of the H's is gone. So that's going to connect to the hydrogen. Sorry, to the nitrogen. And then one of the H's, again, it's not two H's, just one now because the other one's gone. That's going to connect. So that's, these things are gone, and this will just connect right to there. And so on and so forth. Okay. So what you could do is that this is your polymer. I mean, I will draw another one if my screen is big enough and let me. But that's how you do polymers. And the tricky part is going backwards. But then I can make it really easy if you know, if you've been watching my videos. Look for these, look for CON and look for COO, and you want to cut it at this position. Okay, so that means we want to cut it here, we want to cut it here. You look for the CON, you look for the single bond here, look for the single bond there, and you want to cut it. And once you cut it, you just copy and paste. See that blob and that blob? Just copy it. All right, just copy it out. Don't do anything yet. Just copy it out. There's really no skill involved. Just look for that and just copy it. All right, so we've done the copy pasting. Now it's the next part that does involve a little bit of skill. When we do hydrolysis, so condensation polymer is combining two molecules together to form a larger molecule, and there's condensation, and during the process you release water. And when you're doing what we're doing right now, when you have a polymer, when you try to break it down, you are trying to give it water. All right, so we give it water to do hydrolysis. And what is water made of? Water is made of H and OH. And surely, as a year 13 chemist, you can see that one of them gives a carboxylic acid and one of them gives pethiamine. All right, so this is how you can figure out the monomers. Now, for the excellence bit, is that sometimes they will ask you this. All right, if I do this particular reaction in acidic condition, what are my monomers? What are my products? If I do this in the basic condition, what are the products? Explain the difference. and two massive boxes, quite a few lines, and people just go, oh my god, this is too hard, skip. And you're just skipping a really easy excellence opportunity here. Because if you can figure out the thing that I'm drawing right now, if you can figure out that, you can do this last bit and, you know, get the easy excellence. And this is why I think organic is easier. What you want to do here, you just need to understand that in the acidic condition, the acid functional group doesn't do anything because it's a carboxylic acid. Acid doesn't react with acid, they just dissolve with each other and don't do anything there. Now this, the NH2, which is the amine, which is a base, that will get neutralized. So that means they are going to get another H from the acid, because as a nature of as a nature of base, they pick up another H plus. Now if you do this in the basic condition, so it's going to be exactly the opposite. The base doesn't do anything and the acid is going to be neutralized. So you're not going to have COOH anymore. I mean, you will have them at the beginning, but then they will be neutralized. So that means one of the H's is going to be given away on both ends and they'll be neutralized. And you think and then if they ask for explanation, you just go, oh, in acidic condition, I make regardless of acidic or basic conditions, I make these two monomers. But then, you know, in acidic condition, neutralization happens. This is basic, so it's going to be neutralized. In basic condition, the carboxylic acid is neutralized, which then gives me two different products. Boom, excellence. Okay, so it's very straightforward, I hope. But just look for the, you know, when especially when they give you things like this. Let's say blah 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 blah, and they give you carbons and give you like rings and whatnot. You don't need to care, you don't need to look at what it is, all right? You just need to look for the CON or COO. You look for that, you cut it, and you copy whatever the heck they're drawn, just copy paste, complete the ends, and then get ready to get your full mark. Okay, so don't worry about the things in the middle. Next part. Oliver, calculate the pH at equivalence point, question for the titration curve. All right, so that's probably again, that's on my one of the videos I've done. So if you want a more detailed explanation, you can go over there later, maybe tomorrow or Monday if you want to prepare for the exam. You know, that because that's more detailed, because I did that for my online learning. But for pH at equivalence point, let's say for example, if I'm adding conc. If I'm adding HCl to NH3, for example, I'm going to make NH4 plus and Cl minus. All right. So what does it mean by? So this is a weak base. This is a strong acid. Yeah. So what does it mean by equivalence point? Equivalence point means that I have added enough. So think of the flask, yeah? This is my, you done the practical before, I hope you did. No, that's a horrible conical flask, this is a beaker. Like say for example, this is my puree, blah, 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 dripping in. So this is my NH3, I'm dripping in HCl, yeah? So at equivalence point, your moles of NH3 and your moles of HCl is exactly the same, because that's what equivalence means, all right? Equivalence just means the moles are the same. So this is gone, this is gone, and then you have created equal moles of NH4 plus. We don't care about the Cl minus spectator. Don't worry about that guy. So you made NH4 plus. So if you know the initial, so if you know any of these two moles, which you will from the clues they're giving you, they would have, like say for example, they give you 20 moles, 0.1 mole per liter. Then you can easily go and equal CV. You'll find this mole. That means you'll find this mole. That means you'll find this mole, because it's all the same. All right, and then if they go, oh, this is also 0.1 mole per liter, then you can, you know, the number is going to be, the mole is going to be exactly the same. So what is the volume required to neutralize it? I'm also going to use 20 mils because that's how I get the same mole. All right, so the mole is going to be the same. So the 3 moles, like I mentioned, the 3 moles are going to be the same, but you need to just bear in mind in this particular scenario, the mole is going to be the same, but the the concentration of ammonia is going to be the mole divided by the total volume, divided by how much stuff they have in the flask, which is 20 mils of that and 20 mils of that. So it's going to be your concentration essentially halved. All right, and this is a really easy example because the two concentrations I give you are exactly the same. So you actually don't need to do this method to get this particular part. Okay, so if you are wanting to you know, a far more detailed explanation, have a look through one of my videos on buffer solution. I did 2 videos on buffer solutions. I did another video recently on a school exam paper that our school did, which they did very badly in. Have a look at that one, because in that paper there is a equivalence point equation which is quite difficult. You can just find it, pause it, and then give it a go yourself. If you don't get it, then just listen to my explanation. All right, next one, enthalpy of dissociation of calcium into the solubility. How can you explain? All right, what's happening here? Enthalpy of dissolution of calcium carbonate is negative, but the solubility is low. However, for NaCl is positive, yet it is soluble. So this is looking at 3.4 enthalpy and entropy. All right, let's look at this. So you're saying CaCO3, the enthalpy of dissolution is, so that's pretty much just turning into Ca2 plus and CO3 2 minus, and it is saying the enthalpy of this particular thing is negative, but the solubility is low. Solubility is low, so that means it's kind of like this. So they're saying solubility is low. Now, what does that mean? That means this is less likely to happen. So they are hinting this is not very spontaneous. Not very spontaneous. Yep, that's what they're saying. And then for the next part, which is sodium chloride turning into Na plus and Cl minus. And yet it is, so this enthalpy is positive, yet yet it is soluble. So that means it's spontaneous. So this is looking at AQ, 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 AQ. Right, this question is actually, do you need to know the solubility rule for this? I don't think you do. How can I explain how do you explain the observation in terms of entropy change of the solute and the solvent? Well, if you think about it, the two processes always have a positive gain of entropy. So I don't know where you got this from. That looks like that's what I was thinking, Kevin. That looks like a rather scholarship type of question, which is not what I'm here to do, because that's going to take a bit of my time to figure that out myself. Yeah, it's definitely not NCEA level 3, so we'll do that another day because Kim's skull has already been done, so not here to do that with you. All right, so you can work that out, because I'm here for the general public of level 3 chemists, not the top 1% elite students. Do you think 3.4 external will be more like, dude, if I knew what the exam paper would be like, I'll be rich, because I'll tell you what it is. But hey, that's what I meant by doing as many exam papers as you can, because if you grind the exam papers and see all the variety of questions, because one year I swear they had the chemistry student hated NCEA for that. Yeah, there was a question, I think it was 2017 or 2018, where they had something like decaying, and there was something like CH3I, and then was something else, and then they were asking to compare the temperature, the intermolecular forces. That was a really weird question. I mean, you have to be on the best on your best day to understand that. But I think it was 2017 to 2018 is to do with the organic aspect as well. So, if to be safe, I always say do at least 4 years of exams if you're going for triple E. You know, the more the merrier. I've known someone that did all the way up to 2011, which is very, very unnecessary. But you know, when there's a will, there's a way. Okay. Any other questions? Because we do. I think I've got through everything. Hi, Army. Nice to see you here. Any questions? Any questions? Any questions? Because like I said, I'd rather, because there's so few of you, I don't want to go through any. I'm giving you guys more attention. And if you have any questions, just pop in the chat. Because the people that don't want to watch it now are probably playing League because of Clash. Probably can watch it tomorrow or Monday. Dimers. What are dimers? Is that a abbreviation of something? Dimers, you're looking at a monomer and a dimer. That's just, how would you say it? If you well, you have a monomer and another monomer, put two monomers together, you have a dimer. It's stupid. It's just two monomers. It's like protein. You think about a simple protein. Yeah. Acid base hydrolysis. So Kiwi263, I did one just now. You know what? Since you asked, I'll just do it again. You never got it. You know, you probably missed it just now. But here it is, just for you. All right. So if I have a polymer like this, let's make a fancy one. Why not? Let's just chuck a ring structure in there. What should we use? Let's just use nitrogen. Again, I can't fit everything onto this stupid limited OneNote, but you get the idea. Right, I'm just gonna, I can't do anymore. All right. So if this is a polymer, and they go, all right, I need to find the monomers, and they go, all right, I'm doing acid hydrolysis, acidic hydrolysis, and basic hydrolysis, and I want to break this down. All right, how do I do it? So the first thing first, find CON, cut it there, find the CN, just cut it there. All right, and and then you copy paste. All right, so everything on the left, see the thing that I highlighted, copy that, which goes into, I'm just gonna do, rather than doing acidic or basic first, let's just figure out what the monomers are. So copy paste, so copy that there, COCH2CH blob, benzene ring, CO, right, so there's nothing hard about that one. Now see, for that thing in between the lines, so this bit in between the lines, copy that, so just NCH26N. All right, if you can't do that, then I can't help you. I mean, if you can't cut a single structure and then copy paste, you know, I'm sure my year 9s can do that, you know, I'm not saying you can't do it, but hopefully this method will help you, right? So once you've done that, remember polymer hydrolysis, we're putting water in. Water is made of OH and H. So this is incomplete, obviously. This is incomplete, this is incomplete, and this is incomplete. So you're just putting these guys in there. So obviously this is going to be a carboxylic acid, and this is going to be your amines. Oops, I forgot some hydrogens here. All right, so this is your monomer number 1, and this is your monomer number 2, and then together you make a dimer. But yeah, never need to teach that word before. All right, so if once you figure that out, and you need to be able to identify, this is a COOH, this is a COOH, which is acidic, and then you need to understand this is an amine, this is an amine, which is basic. And then if you do acidic and basic, hydrolysis. You just need to understand that, again, just copy paste. You will need to make these two monomers in both reactions. The only difference is that, so I'm just, again, copy pasting. Just copy pasting. No skills involved whatsoever. Just copy and pasting. You can do this in the exam. Like, and then you can just tweak your final answer because you do need to change it a little bit. Alright, so this is just pretty brain dead if you ask me, if you know what you're doing. Okay, now, in acidic condition, acid is going to neutralize the base. We know this is acid, so that's done. We don't need to do anything. This is the base. We discussed this is a base. So what that means is that this is going to receive another H and become positive, because that's what bases do. All right. Whereas in a basic condition, this is fine because that's already a base. The acid, this is going to be neutralized and become CO minus. This is going to be neutralized, become CO minus, and that's your X's. Okay. Next up, can you go through a polarity equation? How to tell? All right. So polarity equation, Haley, is going to be pretty straightforward if you know your shapes. Just remember, here's a really easy way to do level 3 polarity. Because if you can do level 2 polarity, you shouldn't need to worry too much about the explanation because it's pretty much the same thing. You talk about the dipole formation in your explanation. I mean, again, you can go through some of my older videos to look at that. And the other one is look at symmetry, look at the shape, and then look at the shape. Symmetry to the dipoles cancel each other out. All right. So these are the two non-negotiables. You need to talk about them. So for the dipole formation, you can just talk about, oh, the bond between C and O is polar because of the significant electronegativity difference, which means blah, blah, blah. So you form bond dipoles, but because of the shape, you know, that's the same old from year 12. And then the only thing that's tricky is the symmetry. All right. So because you learn new shapes. And the best thing I can tell you, Haley, or any year 13 that do struggle with the polarity, just remember the only thing that have got lone pair of electrons as non-polar is square planar. I say, for example, this. It looks like that. This is square planar. Yeah. So think about like a square piece of paper, and then with an invisible point above it and the invisible point below it. You can't see them, so it's just a square piece of paper. So that's polar. That's non-polar because this they cancel each other out perfectly. So easy tip that I can give you, 2 days before the exam is that if you see any lone pair of electrons above the central atom, don't go, oh, I see these guys are above the fluorine. You told me that's non-polar. Oh, blah, 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 blah. Don't come back to me and say that. It has to be above the central atom. Okay. So if you see a lone pair of electrons above the central atom, that is not square planar. So this includes your bent. This includes your seesaws. This includes your trigonal pyramid. All of the shapes that got lone pairs electrons above them, they are polar, because those guys, they don't, even though we don't see them, they will repel each other. They will still repel the other regions, and then they will distort the symmetry of the shape, and they will be asymmetrical, which means they will be polar. Okay, so hopefully that helps. And Oliver, geez, you guys are getting your money worth of time today. Can you? All right, so dilute HCl. Add it to NH3 solution until the ratio of that is done. Okay, so this is, let me find, should I find it there? This is 2020, excuse me, where's my OneNote? I'm just gonna find, can I find a question that's similar to that? Nope. That was not in there, because this is an exam question for sure, because I've seen it. Let me just quickly find it for you. which one did I do before? Because I don't want to replicate things. Yeah, sorry, I'm just looking at just because this is definitely an exam question, but who cares? I can't really find it. Right, so you got blah 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 5 to 1. So this is a buffer question, yeah. So with buffer, just remember pH. This is your buffer equation. pK plus log base over acid. Okay, so you've given me. You can find this quick, yeah, 2017, because it's definitely on there. So I don't need to find, because I see the 5 to 1. I've gone through all of the questions, so I know what they look like. So it's a 5 to 1 ratio. We don't need to care about. I don't need to solve the question necessarily for you. I just want to show you how we can figure it out. Yeah. So we know NH3 to NH4 plus is 5 to 1, and hopefully you can tell this is the acid. This is a base. So that means pH equals pKa plus log 5 divided by 1, which is just 5, because it's 5 times more. Okay, so this is what it means. The ratio between the base and the acid is 5 to 1. So you just substitute that into the equation. So that's 5. So what's log 5? What's log 5? Where's my calculator? I'll do this in my head. Log 5, log 5 is 0. So pH equals pKa plus 0.699. Okay, so it's, it's when you have, what was your question again? Determine the pH of this value. So you have the pKa that's given to you, and so yeah, there's your pH. You just use a pKa plus a number, then that's that done. And evaluate the ability of this thing when a small volumes of strong acids or base is added. So just remember when your, let me just quickly do this. Just remember when your pH is smaller than the let me be more specific. When the pH of the buffer is smaller than pKa, this means there's more acid. Okay, when your pH of the buffer is, which is in this case, which is more than pKa, that means there's more base. That means there's more base in this, because what is a buffer? Buffer is a combination of the acid and the conjugate base. Yeah. So when the pH is greater than the pKa, that means there's more base. Yeah. If there's more base, obviously this is more resistant against acid additions, because it can handle more acid because you have more base in there. That's essentially what it is. Okay, so you just need to remember that when you have, because we already done the the concentration, because we know that we know the ratio of NH3 to NH4 plus is 5 to 1. So we know there's more base. Well, which I just told you that anyway, but this is just different ways of how you can answer the same question. But yeah, that's pretty much it. Why do I keep going back to this resource sheet? I don't want to go there. Yep. Now, can you do some in a quiz? Can you explain the common ion effect? All right, common ion effect for you, Charlotte. So common ion effect. Say, for example, I want to dissolve. Now, this is you know what? I'll throw in some. In a few drops of, I'll throw in a complex ion equation as well. In a few drops of, as not the best question. Let's just do a small amount of an NaOH and then excess NaOH. All right, so this is an excellence question. And again, might be handy to show you the complex, this thing again. Where is it? So you got the complex sign, which is over here, Zn OH4 2 minus. Just remember that. I'm gonna go back here. So first thing first, whenever you do questions like this, always write down the equilibrium. That's by far your best way to start a question like this. All right, this is your equilibrium. So if I want to dissolve this in a small amount of sodium hydroxide, which is made of Na plus and OH minus, and this is your complex sign. So if I want to put this zinc hydroxide in a solution that already have a lot of hydroxide, that means this the OH minus concentration is going to be a lot. So that means the system is going to shift this way because there's already so much concentration in terms of the hydroxide. So it's going to shift to the left. That means I will have more of this solid, which means the solubility decreases. Now for the second part, when you add excess sodium hydroxide, so that means I have lots and lots of OH minus, and this is where you are going to look at the formation of the complex sign, which is the thing that I showed you just now. Again, you don't need to memorize them. So what it means is that when you have excess amount of, that's a very large plus sign, when you have excess amount of hydroxide, so that 4 means you need a lot of it, and where the hell is it? That's 4 2 minus. All right, so there you go. So what it means is that in this case, I don't need this anymore. In this case, the zinc 2+ ions are being used. So what they do is, I actually shouldn't cross that out. The Zn 2+ ions and the excess amount of hydroxide from the sodium hydroxide, they're going to make the complex ion of this beast. So that means my zinc 2+ is going to disappear. So this zinc 2+ is going to disappear. So what does it do instead? It's going to shift to the right to make more Zn 2+. And as a result, the solubility of this concentration decreases, which means solubility increases. Okay, so this is if you just do a complex sign, a common ion question, that's merit. If you do a complex ion question, that's excellence. Okay. Next one, simply last. I found it hard to know if I need to use His law when I can just do products. Okay. Yes, Kiwi 263. When you get, like say for example, when you get A plus B turning to C, and I give you enthalpy formation of A, I give you enthalpy formation of B. If I give you enthalpy formation of C, you simply just do products minus reactants. Okay. Now, if I give you same question, if I give you enthalpy combustion of A, that's enthalpy combustion of A. If I gave you enthalpy combustion of B, I give you enthalpy of reaction of C, for example, they're not enthalpy formations, you have to use Hess's law. All right. So if you get all enthalpy of formations, like you said, you just do products minus reactants. And for these type of questions, this is only merit. All right. And if you get for these type, when you have to rearrange, the thing like I did before, that's going to be excellence. And Chloe, what are you doing here? You're way. You don't need me anymore. You're already at uni. Stop trolling us. All right. So, Elston. So you got 10. Wait, Elston, what are you doing here? Go away with your uni chemistry questions. These past students keep coming on to chat to troll you. I don't get paid enough to teach you uni chem, man. Ask you uni lectures. I can tell straight away when I see the question that's a university level question. Go away. Go away. And then I see the name, Elston. Yes, of course you're too hard. Good luck. That's all I can give you. Just bombard your lectures. Alright. I think any more questions before? Yeah, like I said, it's pretty quiet in terms of streaming. So that's why I'm not over preparing, because like I said, a lot of my I don't think a lot of my year 13s are going to do the exam. I think they're all going to sit aqueous, because they've done pretty badly. Oh, Ahmed, how died. 10%. I'm just kidding, man. You just do well in aqueous, and hopefully we we even after you've done requiz. Guntus, do we need to know specific situation where fractional distillation must be used? Yes, that's but when we say distillation in general, we are only interested in separating aldehyde before it turns into carboxylic acid. Okay, so I don't think there will be any specific situations, because fractional distillation is a little bit more complex, and I would just go with just distillation. When would you use distillation? To get the aldehyde out of the solution before it has the opportunity to turn into a carboxylic acid, because it has a lower boiling point. Okay. Are there any more questions? Just keep them coming. I'm more than happy to answer any of your questions. I do charge quite a bit for private tutoring, and this is pretty much what you're getting online for free, so do make the most of it. And Ahmed, you must be pretty happy with how Man United is going. I watched the Arsenal game. It was still depressing, but less depressing than how it was a few weeks ago. Definitely on the rise. Alright, I'll just give you no worries, man. No worries, Guntus. So if you, this is because I think because you guys definitely have had it tough for the last couple of years, and this is all I can do for you, to be honest. Any tips to merit thermal chem? If you want to merit thermal chemistry, Haley, is to look at the trends, the periodic table trends, because I guarantee you, I bet my house that you will get questions on thermal on trends, because that's just guaranteed. All right. If you're not, and then polarity and shapes, those are again 100% gonna come up. Learn your shapes, learn your polarity, because polarity tend to be quite easier. And with the intermolecular forces, again, your answers don't need to be perfect to do intermolecular forces. You just need to be able to identify. Just remember, every molecule have temporary dipole force of attraction. All right, just remember, every single molecule have this. Some have hydrogen bonding, some have permanent dipole, blah 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 blah. But remember, all of them have temporary dipole force of attraction, and this depends on molar mass. The more molar mass there is, the stronger the force of temporary dipole force of attraction. And then if you're not so great with the calculations, I don't know, because that's where I think the easiest errors come from. But definitely learn the trends, the shapes, intermolecular forces, and if you can get some of the enthalpy calculations right, I think that's a comfortable 16 points, 15 points for merit right there. Arsenal bigger than Man. I get out of here, Ahmed. And well, we're both pretty bad. The Premier League table shows that, yeah. But we're on the rise, and Arsenal is just going to keep being top 8. Yeah. Your school doesn't teach organics. Oh, that's unlucky. How does the school not teach organic chemistry? That's pretty much the most important part of chemistry. NCEA on how NCEA like questions to be, how NCEA like keywords. I've essentially, okay, so Kiwi 263, so you don't want to do aqueous, understandably fine, because it's probably harder. How NCEA like questions to be answered. Organic, we're not so picky on the wording. Organic is that you just need to know the stuff. Like if you have a flow chart, if you don't know the flow chart, it doesn't matter how good your wording are. It's either you know or you don't. So just make sure that, so the wording is actually organic has the least requirement in terms of the wording. Like say for structure and bonding, if you're talking about periodic table trends, if you misuse terminologies, like for example for intermolecular forces, if you misused terminologies, you are gonna get pinned down like really harshly. For organic, they're more generous, I feel, because you need to know what it produces, and if you do know that, then yeah, it's wording is not so much of an issue. Yeah. And temporary, Oliver, temporary dipole force of attraction is it's in all molecules. Because what is temporary dipole force of attraction? I'll give you an example. Like say, for example, I could have an I2 molecule. I have iodine. Like this is my blob. And then one instance, for this particular instance, I could have, majority of my electrons on the left hand side. Just by chance, because electrons always move around. All right. So this side is slightly negative, this side slightly positive. So you could have another molecule that's doing similar sort of things at the same time, which is slightly negative, slightly positive. This force of attraction is temporary dipole force of attraction, and that exists in all molecules. Okay, so in every single molecular solids, you will have a temporary dipole force of attraction. Organic sucks. Oh, what are all the freaking graduates doing here? Get out of here. Go play your video games. Saturday night, go drink or something. Favorite football player right now, to be honest, I don't have any. Probably Bruno Fernandes, but they're nowhere near as good as how the players were. Favorite player all time, probably post goals, or Roy King, if you know who they are. But yeah, any questions? We'll probably just call it off soon, if because it's mostly just year 13s from previous years. No problems, Oliver. Just grinding exam papers. That's the best advice that I could possibly give at this given time. Okay. Now, obviously, people ask me Ronaldo, Messi, blah, blah, but it's more than that. You just have to, Calcium bromide is not a molecular solid. Calcium bromide is it's an ionic solid. Okay, so calcium bromide, you should learn this from level 2 chemistry. This is a metal. This is a non-metal. When you have a metal and non-metal bonding together, it's ionic bonding. When it's ionic bonding, it doesn't have temporary dipole force of attraction. Okay, Chloe, I'm not gonna answer your question. Go away. Why are you asking me a question? Roy King. Oh, what's wrong with Roy King? Yeah. Poor Lewandowski. It's never lucky, eh? Never lucky. Wait, Chloe, are you being serious? Why are you asking me a question of S2 minus ion having a bigger radius than the atom? That's, this answer. Why are you asking me this? You gain 2 electrons, more repulsion. Oh, jeez. She's forgotten everything again. Oh my god, Chloe, so you're asking me to teach you stuff so you can tutor them. Oh, jeez. Why don't you just send them my way? I only charge them, quite a bit. Yeah, and Haley, you're definitely right with that answer. It just means S2 minus gain more electrons, more repulsion within the energy levels. Therefore, the atom is going to be bigger. The ion is going to be bigger. Yeah. And those of you wondering, there are quite a few ex-students in the chat. See, this is what university does to you. Just bored. Just have to be bored, and then got nothing to do on a Saturday evening. Hop on the ex-teacher's YouTube channel. Oh, Jesus. How can you forget about electron repulsion? That's like the basic part, Chloe. Alrighty, are there any more? If there are no more, I might get in some league games or probably some TFT before I sleep. But maybe I should start streaming TFT. My favorite subject at school probably chemistry, just because my chemistry was my chem tutor was like a legend. He's just too good. Yes, Chloe, we get it. You are a law student. Yeah. Ahmed. Jeez, man. Hey, you'll get better. Trust, you'll get better. Wait for us to thrash, man. Crystal Palace on Monday. Okie dokie. Looks like we all good. Then, yep. If you, like I said, if you have any questions, just go on my YouTube channel. Look for some past papers, and you know, you will find. If you don't get anything, just leave a question in the comments, and I'll get to you. Least favorite subjects at school? Ooh, probably English or art. Any of them, but I stopped taking arts after year 10. But English, oh god, don't get me started on poetry. What a waste of time. But you know, you literally write a sentence, break it down to 5 lines, and call that poetry. Give me a break. Do I know anyone that does physics tutorials? Haley, are you coming from the there is an NCEA Discord channel, which is run by volunteer students, and I'm pretty sure there's someone on there that does physics, like a teacher that does physics. I'm pretty sure. I don't know them in person, but yeah, I don't think there are a lot of people that give up their time like I do. You know, I mean, I do enjoy doing this, you know, because it does help you. But I'm sure if you I'm pretty sure there's NCEA. I'll just pop in the chat. How do I invite people? Alright, so there's the if you do you know, if you're not in that Discord channel, is very, very helpful. Just yeah, go in there. Surely stream your TFT. I don't know, this TFT, this patch, man. Oh, I had 133 LP last night and I tanked all of it. I'm on 0 again. Oh, I just can't hit Grandmaster. So tilting. Yeah. Yeah, definitely go Kevin Fu. Kevin Fu is our Ducks this year. He's blaming me for stealing views from his channel again. Yeah, look up Kevin Fu. That guy is amazing with whatever he does. All right, I'll probably do some TFT stream when I do hit Grandmaster, but I'm probably just gonna go back and climb. Yeah. Well, that's it. All the best for Tuesday, and you know, hopefully you guys do well, and all the best with your future endeavors, and I'll see you guys around. All right, take care. Yeah.